Okay, so on Friday, we reviewed geometry. We did right triangle trig. Oh, hang on. All right, so it's Hannah's birthday. We got a lot of choir kids in here. This ought to be good. I'm not going to sing because I'm going right in the mic, and nobody wants to hear that. Woo! Yay! It's kind of a slow, sad rendition, but it sounded good, I guess. Okay. So on Friday, we did right triangle trig, SOHCAHTOA, right? And the keywords there are right triangle. Okay, the stuff you did in geometry, the stuff we did on Friday, the SOHCAHTOA setup, that is all for right triangles, okay? Because I don't have a hypotenuse if I don't have a right triangle, right? So today we're going to look at what if we don't have a right triangle. We can still use trig. It just doesn't look exactly like what we did on Friday because that's only for right triangles, okay? Make sense? So here we have, so it says previously you learned how to solve a right triangle. We will now look at how to solve an oblique or non-right triangle. So remember, oblique is like, if it's right, it's standing up straight. If it's oblique, it's leaning over. Your oblique muscles are on the side. Remember all that good kind of stuff. All right, so we have this triangle here, not a right triangle. We have three sides, which means that I could draw any one of these three could be the base. And then whichever one's the base, the height would have to be perpendicular to it. So we're just going to use the one that's on the bottom to be the base, and we're going to draw in the height. Height is always perpendicular. But keep in mind, I could use BC as the base, which means I draw the height from A and so forth. So we're just picking one. And this is the height of the triangle. All right, so we are going to, we've taken our oblique triangle and split it into two right triangles. You agree with that? And we know how to handle right triangles. So what we want to do is we want to come up with something where we can solve this triangle without knowing the height, just based on the side lengths and the angles. And so we're going to use what we know from SOHCAHTOA and our right triangles to develop something. So we're first going to look at this little right triangle right here. And we're going to set up something for A. Okay, so this is an angle. The lowercase is the side length. So I can say that I know that the sine of angle A equals, well, sine is opposite over hypotenuse, and this is a right triangle, so I'm okay. The opposite is the height, so that's h, over the hypotenuse, which is the side length, that is b. Okay, everybody agree with that? So now we're going to take this, we're going to solve for h. So I'm going to multiply both sides by b. I get b times the sine of a, that equals h. Okay, everybody good with where all that came from? All right, so then we're going to look at this right triangle, and we're going to use angle B. So I know that the sine of angle B equals the opposite, which is the height of the triangle, over the hypotenuse, which the hypotenuse of this triangle is side length A. And then I'm going to solve for h, so I'll multiply both sides by A. I get A times the sine of angle B equals h. So just some basic right triangle trig stuff to set that up. Then I have these two little equations that both equal h. So since they both equal h, I can take this, which is equal to h, and substitute it in right there. Would you agree with that? Basic substitution. So that means that b times the sine of angle A equals A times the sine of angle B. So we're going to kind of rearrange this a little bit. I'm going to start by dividing both sides by little b. So this gives me the sine of angle A equals A times the sine of angle B over little b. Then I'm going to divide both sides by little a. So that gives me the sine of angle A over little a equals the sine of angle B over little b. And that right there is part of the law of sines. And I say part of because we're missing the C part of this. So what we could do is we could, like I said, draw the height from A, and then we could do all this again, and you just end up with the sine of C over C. So you can just trust me on that, all right? Basically what it boils down to is it's a ratio. The sine of the angle over the side that's across from it equals the sine of the angle over the side that's across from it. That's it, proportional relationship, all right? Most of the time your triangles aren't labeled A, B, and C anyway, so it really doesn't matter what the letters are, right? So this is our law of sines. So the law of sines can be used to find side and angle measures given two angles in any side. So that's angle, angle, side, or angle, side, angle. Or two side lengths and an angle outside of them, and that's SSA. So those should sound familiar. You used those acronyms when you were proving triangles congruent. So if you remember from geometry, you can use angle, angle, side, and angle, side, angle to prove triangles congruent. You cannot use side, side, angle because there's no S in geometry, right? Now, I know quite a few of you had Miss Williams. I know she would never actually say that in class, but I do say it because I want you to remember that it doesn't work for that. But we can use it, and the reason you can't use it to prove triangles congruent is because it's the ambiguous case. So we have a whole separate lesson on that tomorrow. Today, we're just going to focus on these two. So it's two angles in a side. Either the side is included in the two angles or it's not, and we'll look at that in just a second. If that's the case, then we can use the law of sines, which just looks like this. The sine of angle A over little a equals the sine of angle B over little b, which equals the sine of angle C over little c. Anytime you use a proportion, you're only using two at a time anyway. There's three in the equation, but like I'd pick these two or these two or these two, but it doesn't really matter because they're usually not labeled anyway. Depending on, you could see this also as A over the sine of A equals B over the sine of B, like the whole thing, just the reciprocal of it. That's fine too. It depends on what textbook you look at, what formula chart, the preference of the person, whatever. But when you show like where it comes from, this one is the one that kind of naturally happens. All right, so let's look at what we're doing. Now we have the law of sines today, law of sines, the ambiguous case tomorrow, then we have a law of cosines. So eventually you have to decide which one is like, here's a triangle, which one of these am I using? Today, obviously, it's only law of sines is what we're talking about, but I still want you to be able to look at these and understand what this part right here means, right? And there's a couple of different ways to remember it. Some of you will remember it by angle, angle, side, and angle, side, angle. Others of you will remember it a different way once we get there, whatever, but I'm just going to point it out to you. So when we get this triangle, not a right triangle, we're going to have to use trig. So we have to decide, is it law of sines or law of cosines? So we look at what we are given. We are given two angles and a side. Is this side included between the two angles? No, because if it was, it would be this side right here, right? If I was given this side, it would be angle, side, angle, but I'm given this side, that's what makes it angle, angle, side. So this is an angle, angle, side situation, which means, hey, I can use law of sines. Okay? You don't have to label your triangle ABC. That's really not necessary because the concept is more important. The sine of the angle over the side across from it, and so forth. So I'm looking for x. That's across from 104. So I can set up my first fraction. The sine of 104 over x equals, and then 47 is across from 15, the sine of 47 over 15. And I have set up my proportion. How do I solve something like this? No, not at this point. No, how do I solve this to get x by itself? Cross multiply. So I can multiply x times the sine of 47 equals 15 times the sine of 104. Then I want to get x by itself, so x is equal to 15 times the sine of 104 over the sine of 47. So before you punch that in the calculator, let's make sure we're in degrees. So remember, you can do shift mode 3 for degrees. And then for this one especially, I would use the fraction button because that's going to help you not have to do a bunch of parentheses. But remember, when you do that, you have to close the parentheses on your trig stuff or it gives you an error. Okay, so type that in. Let's see what we get. You never touch the calculator until the very last step. Three decimal places. 3 decimal places. Okay. And you should get 19.901. Make sure that's what you get. Don't just copy mine down because we will make sure we're using the calculators correctly. And this has units on it, so we have to make sure that we have correct units as well. Everybody good on all that? Any questions? All right. So let's look at number 2. I, again, am given 2 angles and a side. Is this side included in these 2 angles? Yes, which makes this one angle, side, angle. What's the difference? Honey, I don't know how you got through geometry. All right. All right. So I'm looking for x. X is across from 42. So the sine of 42 over x, so it's the sine of the angle over the side that's across from it. And then across from 63, I don't have a side length, and across from 28, I don't have an angle. I got to have one of those 2 things to be able to set up my next proportion. What is the, can I find the side or the angle easily? The angle. Okay, so do I just do 90 minus 63? No, not in this situation because it's not a right triangle. I add these 2 together, subtract from 180, and what do you get? You have a calculator in front of you. Yes, 75. And again, for this, use the calculator. It's in front of you. Use it so you don't subtract wrong on something simple. Should you be able to do it without one? Absolutely. But, you know, it's a whole different issue. So that means then I'm going to have that's equal to the sine of 75 over 28. Be careful that you actually take the sine of the angle and not the side length, and that you have the correct corresponding pieces, right? And so we can write all this out, but I am just going to multiply these 2 and divide by this. So this is really just x equals 28 times the sine of 42 divided by the sine of 75. That's how you cross multiply and divide, right? Shouldn't have to write out every single step every time. So do that, get that typed into the calculator correctly. And make sure you get this answer. What questions do we have? Anything? Easy enough. It's just a proportional relationship, so it's easy to remember too. Okay. So let's look at number 5. A pilot begins a flight traveling 80 miles northwest. To avoid a storm, he makes a turn, then returns to his original location. The diagram of his flight course is shown to the left. Find the total distance of the flight. So I start here, go 80 miles, turn, go another distance, turn, go another distance, come all the way back. It says find the total distance, which means I know this is 80. I need to find these 2. I'm going to call this x and this y. Okay? Which means in the end, and I'm going to tell myself this right now, I'm going to have to add all, I'm going to have to add all those up, so that's going to become 80 plus x plus y. And because I'm going to have to find both sides, I'm pretty sure I'm going to need this angle, so I'm going to go ahead and do that now so I don't do anything weird. So if this is 108 and this is 15, what's this angle measure? 57. 57 degrees. Okay, so let's start with x. So to find x, x is across from 108. So I will have the sine of 108 over x equals, and then I don't want to use the y because I don't know what that is. I need to use this side length. 80 is across from what? 57. So then I'm going to take the sine of 57 over 80. Okay. Everybody with me on that? Cross multiply and divide, so I get x equals 80 times the sine of 108 over the sine of 57. Okay? Those of you that are pushing buttons on the calculator already are wasting your time because we're not done, right? You wait 95% of the time to the very last step to ever touch the calculator. I don't care what x is. Like, it's part of the question, but what the decimal for x is, completely irrelevant. And I am not going to find a decimal and then type it back in. I stop right here. I move on to y. Okay, so then y is across from 15. So I have the sine of 15 over y equals, and then I use the same second fraction because my only other option is using this one, and that would be a mess. So we're going to use that again. Equals the sine of 57 over 80. That means y equals 80 times the sine of 15 over the sine of 57. Okay? So we actually have a couple of options on how we would solve this. We could have typed this in, but then we would have to store that in x in our calculator. We could type this in, store that in y in our calculator, which is a skill that we need. We don't have to do it on this one, though, so we're not going to talk about that right now. Instead, we know that it's supposed to, I just have to add them all up. 80 plus x plus y. This is x, this is y. So in this calculator, type 80 plus, use your fraction, type this in, plus, type this in, and you only do it once, and you don't have all these random decimals everywhere. Does that make sense? One step, total, just at the very end. And if you do it all correctly, you should get 195.409. Make sure you get it. Make sure that's what you get. Miles. Okay. Remember, you want to work smarter, not harder. Just because you have the calculator in front of you does not mean you pick it up and push buttons as fast as you possibly can. It's not the best way to do it. And for sure, use the fraction button so you're not having to use thousands of parentheses with your division. Okay. What questions we got? Anything? All right. Good. Uh-huh. No, there's not really a backspace. Well, no. How do you just delete? Yeah.